Hello and welcome to today's lesson. We're looking at Circles and Polygons Unit 1 still, Lesson 7. In this lesson we're going to be looking at the specific shape of the parallelogram and looking at how side and angle measurements using different properties work within a parallelogram, determining how angle measurements using consecutive angle properties in a parallelogram, and then also looking at parallel diagonals and what happens with those measurements within a parallelogram. Now, some important things to remember when we're looking at the properties of a parallelogram. Parallelogram is a quadrilateral whose opposite sides are parallel. The opposite sides are also congruent or the same length. So a rhombus, a rectangle, and a square are all types of parallelograms. So they might have some specific properties within their shape, but anything that we discover as we work through today is going to work for all of these shapes, not just parallelograms. So when we're looking at our shapes, we want to make sure that there's not any special properties as far as all four side lengths being equal, dealing with right angles, but we can see how those properties would work as we go through this lesson. So our first conjecture is the parallelogram opposite angles conjecture, which states that the opposite angles of a parallelogram are congruent. So when we're looking at opposite angles, we're talking about the upper left, lower right. Those two angles are congruent, as well as lower left and upper right. And the reason for that is the properties of parallel lines. If we look at this picture, we have situations where we have two sets of parallel lines. So if we look at our first set of parallel lines cut through by a transversal, we know that there are only two possible options for the angle measures in this entire picture. Everything could be A. We can get that with a vertical angle. We can get that with a corresponding angle, vertical angle, or it would be the linear pair of B. So we can get that by A plus B equals 180, a vertical pair, a corresponding angle, and a vertical pair as well. We've seen this before in dealing with other shapes, that we have all of these similar angles on one side. The difference with a parallelogram is the fact that the other side lengths are also parallel. So then we know that any angle in this region can only be one of the two options. It's either angle A or angle B. And we can use the corresponding position for A to transfer over here. Now we can see that the A's are congruent to each other. We can transfer over the B, and then based on alternate interior, we can see that those two angles are congruent to each other. Okay, so using the idea of parallel lines and transversals with what we know about angle measures in parallel lines, we can help prove this conjecture and show that it works. Now, our next conjecture is the consecutive angles conjecture. So in a parallelogram, the consecutive angles are supplementary. Makes sense if we think back to our last slide. Once again, parallel lines cut by a transversal. There are only two possible angles that we can have, A and B. We know that A plus B equals 180. Which is a linear pair or a supplementary angle pair. So now, we can use that idea to solve for a missing angle. So notice in this picture, you're only given one angle, and we can use the opposite angles conjecture to find the other 110, and then we can use our consecutive angles conjecture to know that the consecutive A and B have to add up to 180, and we can solve for A, which would be 70 degrees, subtracting 110 from each side. And then we know based on opposite angles that we have the other 70. So we can see how the parallel lines in a parallelogram really fit and give us those two measurements. Our next conjecture that we have is the opposite sides conjecture, and this is basically the definition of a parallelogram. We have two sets of parallel sides, so the opposite sides of the parallelogram are congruent. So if we're looking at the left and right side, those measurements are equal to each other. The top and bottom, their measurements are equal to each other. And then our next conjecture is the parallelogram diagonals conjecture. The diagonals of a parallelogram bisect each other. And remember what it means to bisect. We're cutting it in half. So AE is equal in length to ED. Okay, so those two measurements are equal or congruent. The same with BE is congruent to EC. So we have the situation, the diagonals cutting each other in half. Okay, also gives us some similar triangles when we're looking at that situation. So now, we've got a few problems here. Try to fill in the missing pieces. If you want, press pause. After a couple seconds here, I'm going to go through and find these missing measurements. So if we have a parallelogram, and that's one thing that we need to know in order for these properties and conjectures to be true, then we can start looking at the consecutive angles, knowing that 118 plus C equals 180. Subtract 118 from both sides, and we get 62. Once we have that measurement, we know that opposite angles are equal to each other, so we know that A is 62, we know that B is 118, and we could verify this knowing that we have a 4-angle shape, adding up all 4 angles and making sure that we get 360 degrees for the total. Here now we're looking at some measurements. So we're looking at length values, remembering that the diagonals bisect each other. So X has to be 9 inches, okay, having the two measurements match going from corner to corner. And then Y would be 8 inches. Z, top and bottom, opposite sides of a parallelogram, are equal in length. And then finally, solving for W, we have to set up the equation 2W plus 2 equals 12. Working through our solving steps, we have to undo the addition first, and we get 2W equals 10, and then undo the division, or undo the multiplication with division, and we get W equals 5. And remember, whenever you're solving, especially if it's in a test situation, make sure that you take your answer, plug it back into the equation, and see that it does work for the specific problem. Okay, finishing up here, finding some missing angles within a parallelogram. We know that we have the opposite angle conjecture. That allows us to copy the 70 degrees up into angle B. Now we have some triangles that we're working with. So we can use the idea of the triangle equaling 180, or the triangle angle conjecture, to know that, and we're going to have to put a new letter in. Let's see, let's go with D. D plus 70 plus 50 equals 180. And then we can work through and solve for D. D plus 120 equals 180. D equals 60. So we have that measurement. And once we have that measurement, then we could also look at parallel lines and transversals. We can see that we have some pictures that look like they match. How can we prove that they match? We can use the parallel lines and transversals. So we've got the parallel lines top and bottom cut through by this transversal, and we know that alternate interior angle pairs are congruent. So that means that C has to equal 60. And now we have to kind of change our perspective to solve for A. Once again, we've got the parallel lines on the left and right side, cut through by the same transversal, and now we have alternate angle pairs with A and 50. So the A has to equal 50 degrees. Now, if we take these two triangles apart, we can see that the two triangles are congruent, so it makes sense that the three angles of the lower triangle and the three angles of the upper triangle match each other overall. Finishing up, just understanding how the shapes work together. Remember what a quadrilateral is, four-sided shape. So once we know a shape is four-sided, it can start to fit into different categories. Notice how the kite is a shape all by itself. When we're looking at the kite, consecutive side lengths are congruent, and that creates its own set of properties. Trapezoid, we have a set of parallel sides, and then the opposite sides could be equal. That would be an isosceles trapezoid, or they're not equal in measurement when it would just be a traditional trapezoid. But the trapezoid has one set of parallel sides. And then we work into the parallelogram, two sets of parallel sides, a rectangle, two sets of parallel sides with 90-degree angles, a square, two sets of parallel sides, all sides are equal, all 90-degree angles, and then the rhombus, we have two sets of congruent sides that are parallel, but they are not 90-degree angles. So we can see all of these shapes fit under the umbrella of a quadrilateral, but each one of them has their own special properties. So we've got our assignment for today, Lesson 7 in Schoology. Good luck, and let me know if you have any questions. Have a great day.